various emotional appeals, lack of fact-checking, even there's disinformation is more severe, and that actually is done to harm individual or the society or manipulating the public opinions. Now, there are various forms in which this appears, particularly the disinformations like fake news, rumors, it can be clickbait, the propaganda, the satire, uh, and also it can actually come through various sources, like it can be through the newspaper, social media platform, messaging applications. And when you talk about particularly the bilingual part, uh, the translation from one language to the other language may further add a lot of noises, okay? And that can actually be more problematic in detecting missions. So in your presentation, we'll show that how uh, Indian languages particularly, which is a multilingual country, I'll show you some of the languages that we have been working on, the challenges that we have faced, and even for the modeling these languages have a lot of nuances. Now, why this language matters in your research? Because worldwide, there are more than 7,000 languages, and 90% of them are considered to be low resource. Now, there are various challenges due to this multilinguality. For example, in low resource scenario, we do not have the fact checking tools, the resources. Algorithm bias will be very important because your model might have trained on a small amount of data that may actually introduce some kind of bias. Then there are lack of local journalistic infrastructures, political exploitation is another one, and a lot of cultural nuances may be there with the language. Now, when we talk about, when we deal with these multiple languages, in a particularly involving the minority languages or underserved language, the detection, as I mentioned, will be even more difficult compared to the high resource language. Now, this is what the India's landscape. So the linguistic diversity, if you see that in India, we actually have more than 1,500 languages. And they are derived from almost all the major language families, for example, Indo-Aryan, Dravidian, Austroasiatic families, Sino-Tibetan families. So 22 languages are officially approved, and 122 languages are spoken by more than 10,000 people. Some of the languages like Hindi, Bangla, they are Bengali, they rank very high in terms of number of populations. And morphologically, the linguistic structure wise, they are very different, particularly from the English language. And also, even within the Indian languages, so if you go from eastern side to the northeastern, or to the southern part of India, the kind of languages like we speak, like Tamil, Telugu, they are spoken in the southern part. They are actually different from Hindi, okay, which are predominantly spoken in the north part. Also, we speak in, let's say, most of the speakers are bilingual. So they have a tendency to mix the languages. We call them as a code mixing, okay, languages from one language to the other. So how to deal with such kind of phenomena, whether there is a mixing of language, let's say English and then any of the Indian language, even among the Indian language. So those are the challenges of dealing with the Indian languages. Government has been taking a lot of initiative. For example, one initiative we call them as part of India AI mission. It is the Mission Bhasini, and there our target is to empower the citizens of India by to make them digitally literate by connecting them. And so you want that all the information, maybe in the judiciary, maybe in the education, maybe the governance, whatever information is available, agriculture, health, etc., everything should be made available in the media language. And when you want to attempt to digitize them, particularly for the extremely low resource languages, because out of 22, all are not very high resource, except Hindi, Bengali, 3 or 4 languages if you leave. So we have a lot of challenges. So that will be the challenge in dealing with Indian language. Now, in our research, we'll be presenting some of the work that we did during 2020, 23, 22, this region, this time span. But nowadays, you, all of you know that generative AI, particularly the NLP research, has evolved. Large language model has taken the forefront. And also, because of this vision language model, large language models, the automatic generation of the content is much more easier. And that actually is also problematic. For example, the deepfake videos, if you see that there has been 5 times increase, and since 2019, text generation through the AI tools, it has also increased tremendously. And there are, by 2024 reports, more than 1,200 fake news sites are also introduced. Synthetic ID creation is also not, let's say, unthought of these days. And there are plenty of fake personas are being reported. In Twitter, almost 25% of the Twitter account are actually managed by the bot. And those can actually generate some content which are not very acceptable, which may propagate the misinformations in the other networks. In India, also in 2024, the general elections, the AI was extensively used. And these are some of the statistics that I'm showing you here. For example, deepfake videos were created in different languages. And detecting them was very hard. So the political leaders who actually did not spoke, that actually was circulated. 15 million people, they were connected in more than 500 WhatsApp groups, including these deepfakes. So it was really an important issue to detect that how these deepfake contents that are generated intentionally is to be recognized. And also, as I mentioned, that due to this linguistic, cultural, and diverse political context, this even coming up with a very robust algorithm is a challenge. So we actually had seen that apart from English, sort of the other languages, see that the existing data sets that we have these days, there may be more. So we have listed few of them. They are actually in the multilingual misinformation data sets. And you can see their sizes compared to the English will be very, very smaller. In India also, there have been few resources. We also have created few resources for doing the misinformations. And as I mentioned that when you deal with the multilingual, the varieties, the linguistic diversity is very crucial. Most of the models that are actually trained on the high resource language like English, how to adapt them for the Indian languages, okay, or the multilingual scenario. So proper domain adaptations, the transfer learning, the cross-lingual embedding, the multilingual embedding, this actually have been playing a very critical role. But some of the languages, for example, as I mentioned, although we are now in the era of large language model where you don't have to, let's say, do the traditional NLP from the morphology to the syntax to the traditional, let's say, the POS tagging, parsing, or the semantics analysis. We need a lot of data, okay, high quality data. And there are various models, but whether this model work, how they actually perform for the low resource language, that is a concern. So how to actually fine tune them by creating the proper instruction fine tune data set, by preference based fine tuning data sets. Also the computability is a problem. So we do not have the academic institutions when we deal with this kind of models, we do not have a lot of computing power. So how can you balance trade-off between them? That on one side you have the accuracy, other side you have the computing resources. So we actually need to balance them. And in one of our research that we had done, we tried to see that set up a multitasking framework for fake news detections, particularly with the help of novelty and the emotions. Now let us see a bit that why novelty and emotions are helpful. Okay. So for example, the novelty means that we need to detect whether a information is new or not, that you have not seen so far. So suddenly if you see something which you got a lot of attraction because that probably that information you have not encountered so far, then that actually gives a kind of surprise to us. And this notion of surprise can attract our attention immediately. And we say that, okay, since we have not seen so far, probably this information is new or the novel. Okay. And if you see that the fake information, the misinformation, typically will actually ignite more surprise in your in ourselves, and that actually will always be considered as novel, okay, compared to a real news. On the other hand, if you see the emotions, particularly that high moral emotions always will be driven very speedily, and there are different kinds of emotions you can play with. But if you we actually discuss with 7 different categories of emotions, where you see that fear, disgust, and surprise, this kind of elements of emotions, they actually have some relations with the misinformation, the false stories. Whether the true stories, they are actually inspired by the emotion of joy, the sadness, the trust, the anticipations. Now, what we did is, for example, in the slide, you can see in the lower part that garlic water can cure coronavirus. So if you get this kind of information, say headline, so that actually is, it appears to be very novel information to us. And also it actually shows that, okay, a kind of very surprising, or let's say you can say that, okay, it is a kind of new information, good news, it will do a kind of joy kind of emotions to us. So we may actually consider it to be novel, and also it may consider it to be positive emotions, which in this case is not, because if you actually see the real stories, and if you look for the combinations of garlic and cure, these particular pairs probably will never find into the real news. So now in our case, what we try to find out is that whether this novelty and emotions driven misinformation detection. So these two are considered as the auxiliary tasks in our model. And based on that, we design a multitasking framework where the primary task is the misinformation detection, and the auxiliary task is the novelty detections and the emotion recognitions. And based on that, we actually perform the primary tasks of emotion recognitions. And we did it by with the shared representations, with the novelty, then the emotions, and then we perform the proper evaluation of the systems. We extensively evaluated that, and we have shown that it actually performs better compared to the state-of-the-art systems at that point in time. So what we did is that there are 2 different phases. In phase 1, that we actually want the emotion recognition is performed, because all the data that we have used, they are not emotion leveled. So we had to build a emotion classifiers, and it was mainly based on, we actually perform the emotion recognitions by the existing data sets. Like some of the data set, like Go emotion is one data, and then there was another data that is a collections of 20 very big data sets that curated the multiple emotion recognition data sets. So we use everything, and then we used only the same 8 different emotion categories. And then we build the models. At that point, it was not LLM based, so it mainly we had used the YLSTMs followed by multi-layer perceptrons model. And then we have 3 different models now. In case of novelty detection, what we did is that we retain a model on the Quora question pair datasets. Okay? And we pose this problem as a textual entailment problem. So you can consider there is a premise, there is a hypothesis pairs, and you have to see that whether premise and hypothesis they entail with each other. And if they are not entailing, then you can consider probably there is a chance that it may be the misinformation. Okay, that was the main idea. So the Korea question pair dataset was actually used for the novelty detections. And so we have two different models, one for novelty detection or for emotion recognitions. And we have three different loss functions. And we combine them together with different weights like alpha, beta, gamma. You can see that different weights for three of these tasks. And through empirically, we set the values of this weight alpha, beta, and gamma to be one everywhere, because that actually produce the highest performance. So these are some more information. As I mentioned, that the architecture for novelty detection was BILSTM followed by the attention mechanism. And we have two-level problems here, whether a particular pair of information is novel or not, that we have to decide. The other one, whether it is duplicate. Duplicate means it is not novel. Okay, so there are binary classifier we created. On the other hand, for emotions, we have almost 300,000 sentences were annotated with different 8 different emotions. And we have further mapped them into 2 different broad categories. For example, anticipation, sadness, joy, trust, they are actually the 2 emotions. That means they are related to the real news, whether the anger, fear, disgust, and surprise, and the false emotion. That means they can be leading towards the false news, or you can say it is a kind of fake news or the misinformation. So this way we have trained these 2 models, and we posed it as a, for example, initially there was a premise and hypothesis. Hypothesis is my target news, and the premise is the source news. So each of them is represented by LSTM. Okay. And first the globe embedding we consider, plus the BART embeddings. And then there is a concatenation layer, one representation coming from the hypothesis, one from the premise. We concatenate them. And then we have 3 different specific tasks. Okay. One for novelty, that checks whether it is novel or duplicate. Another for emotion, that checks whether the first category of emotion or second category of emotions, where we have grouped the 4 in each of these 2 different broad categories. And finally, whether the fake news that actually say that, okay, whether the premise and the hypothesis, they are in sync or not. That means whether they are agree or disagree. If they are agreeing, they fine. If they are disagreeing, then there is a chance that it is not correct. So we actually conducted experiments with 4 different data sets, here, like ByteDance, FNC1, COVID stance, and fake news detections. And there are different levels, for example, in this data. And why we have chosen this data? Because our problem was, we posed this problem as a kind of textual entailment problem. Okay. So we actually chose because of these 4 specific data sets, because we had the premise and hypothesis pairs kind for each of these data. Okay. And we obtain we have shown that in almost all the settings, okay, that we had done, our proposed system is considerably better. And also we have compared with single task model versus the multi-task model. So single task means the misinformation detection module is performed without the help of emotion and the novelty detection. And we have shown that, okay, particularly when we do the multitask setting, then we got very good improvement in the range of, let's say, 7 to almost 28 kind of percentages across the different data sets. Okay, we had other follow-up work. Maybe I can skip this, and Rina can talk a bit about the multilingual part. Rina, if you cannot share, then probably I can do it for you. What do you want?
Thank you very much, sir. I can share it from my side, I think.
Yeah. You can share?
Yeah.
Then I can unshare.
Okay. So thank you very much, sir. Hello, everyone.
You have not shared, I think. I cannot see.
Just a second.
Yeah.
I think it's visible now.
Yeah, we can. Yeah.
So in the first part of the presentation, you have heard about the uni-model misinformation detection and also about the nobility and emotion, how it play inevitable role in misinformation detection. In the second part of the presentation, I will be discussing about the multimodal misinformation detection in the context of multilingualism. So here in this direction, the multimodal misinformation detection using multilingual text is the first work. And in this work, what we are trying to solve a specific kind of misinformation, like whether the original image is sharing in different textual context. So the real image is real, but the textual context is different. So for solving this type of problem, here we have first created the data set, and after that we have developed a novel framework, and then we have performed zero-shot experiments for proving the robustness of the model. So first of all, we will discuss about this novel data set. Then we have collected two types of instances here. The first one is fake and second one is real. So it is basically a multimodal data set. So what it is, in this data set, we have taken help of the existing data set, that is factorial data set. Here in factorial data set, it is the pair of fake claims and images. So this fake claims and images, we are considering it as a target instance, and we are extracting some kind of background information available over the internet as the background knowledge. So here we are considering two things. For each image text pair, we are extracting the background information. So available image text pair is considered as the target, and whatever we are extracting through internet, that is the source, and we are considering it the background knowledge about related to that particular fake claim. For the real instance, we have extracted the claims from News 18 and ABP Live, and here also we have again extracted a source information available on the internet related to that particular data. So in this way, what we have done, first of all, we have selected the images, because in factorial data set, there is one claim, and corresponding to that claim, there are multiple image URLs. So we have to just take single image. So for that purpose, we have used clip model to select most relevant image corresponding to that particular claim. Now, by using that particular image, we have performed Google reverse image search to extract related information, and after that we have extracted information from multiple sources. So as the on internet, sources may be credible, may not be credible. So for that, checking the credibility of sources, we have calculated media bias scores for each source, and the most relevant source we have just considered by considering this annotation, like very high and primary factual sources. This media bias scores gives this annotations, and based on that we have taken the sources from these three categories only. So in this way, we are having target source image pair as well as source text image pair, and after that we have annotated these pairs. So in our data set, basically three things. First one is multimodal target, second one is multimodal source, and third one is the annotation. Annotation here is either fake or real. So annotation also we have done in two different steps. First one is, since we have taken fake claims from the factorial data set, and these claims are already annotated as fake, so we are directly considering it as fake. Another is real instances we have collected from the News 18 and ABP Live, and these are the credible sources, so we are considering it as real. So now this is the direct annotation. After that, what we have done, we have also performed named entity recognition based matching for the labels. Here we have used a formula like a number of common entities present in both source and target divided by the number of entities in target. So, and we have set the threshold 0.5. If we are getting the value greater than 0.5, then we are considering it as the source, otherwise we are discarding it. So in this way, we have also checked the agreement score between automatic annotation and any are best annotation. So here we are getting 91.3 for Hindi, 89.5 for Bengali, and 86.3 for Tamil, which gives a better understanding about the annotation. Now at the end, after annotating, we are having multimodal source, multimodal target, and the labels. So in this way, our data statistics is like this. The total number of instances we have created is 10,473, out of which 5,633 are real and 4,840 are fake. So all the instances are from 3 different languages, Hindi, Bengali, and Tamil, and among these 3, more number of instances belong to Hindi. So we have collected these data instances from different domains like politics, COVID-19, social issues, health, and religion. And further, we have split this data set into 80-20 ratio as the train test ratio. Now come to the proposed model. Then after preparing the data set, we have developed a model which takes source multimodal data and target multimodal data as input. Here what we are doing, we are considering multilingual word as the text encoder and ResNet 18 as the image encoder. So for the source also, we are considering these two encoder and we are getting the combined multimodal features. For the target also, we are getting this text and image multimodal features. And then we are applying contrastive learning. Here supervised contrastive learning. So how we are applying it? Let us discuss step by step here. So first of all, we are applying this supervised contrastive learning again to find out the nobility here, like whether source and whether target are related or not related with each other. And after that, whatever the things we are getting, we are extracting the intermediate features, that is the 5 and 2-dimensional features from the nobility model, and then separately we are extracting the image emotions. So by using another pre-trained model here, so we are extracting image emotions, and again we are not taking the end result. We are considering again the intermediate representation, that is 5 and 2-dimensional representation, and then we are combining both the representation, that is nobility aware representation and image aware representation, and finally we are passing this combined representation to a multi-layer perceptron networks with 2 hidden layers and 1 output layers, that is the softmax layer, for the detection of fake and real classification. So here this is the detailed description of the nobility model and emotion model and misinformation detection model. In nobility model, as I discussed, multilingual word we are using, which extracts 768 dimensional text features, and we are using ResNet 18 for extracting visual features. Then we are concatenating both the features and passing it to fully collected layers and getting 128-dimensional representation. Then we are applying supervised contrastive learning here, and finally we are taking the intermediate representation, that is the 5 and 2-dimensional representation here. Similarly, in emotion also, we are retraining the model by using emotion dataset, because we don't have the emotion labels in our dataset. So unbiased emo dataset and art photo dataset we use for pre-training the model. And then we are getting different emotion labels like joy, love, sadness, fear, surprise, anger kind of thing. So we are classifying these 3 models, these 3 levels, that is joy, love, sadness, into emotion true, and fear, surprise, anger into emotion false, for making the problem as binary problem. And then we train this model, and again we take the 5 and 2-dimensional emotion aware representation here. Then further in misinformation detection, with concatenating both the features and again passing it to multi-layer perceptron network with 2 hidden layers, and then we are getting the fake and real classes. So coming to the experiments and result, we have performed the experiments using the PyTorch and NVIDIA GeForce RTX GPU. Also, we have used Adam Optimizer with 128 batch size and 100 epochs. And for supervised contrastive learning, that is for the nobility model, we have trained the model till 1000 epochs We have splitted the data as 80-20 ratio and calculated F1 score, accuracy, micro and weighted average as the metrics. Now we have also performed some ablation studies like with background knowledge, without background knowledge. I'm repeating here, with background knowledge means with the source information that we have extracted from the internet sources, and without background knowledge means the data instances only with the target. So here we have performed different ablation studies, multilingual word plus ResNet. Here text encoder is multilingual word and image encoder is ResNet, and then multilingual word plus ResNet with background knowledge. Then unimodel plus visual emotion model means just the target text and visual emotion features. And after that, multi-model and visual emotion, that is source, target, and visual emotion features. And multi-model plus novelty, that is proposed framework without emotion module, that is the supervised contrastive learning only. So we have performed these ablation studies along with our proposed model. We have also compared our system with some state-of-the-art models like multilingual word plus agent transformer and even adversarial neural network. So here this is the result that we are getting. And what we have observed after getting this result is that we are getting 2.46 accuracy gain from the background knowledge. Means without background knowledge and with background knowledge, when we are performing the experiments, we are getting better result when we are embedding the background information. Also, we are getting some 21.77 over target baseline. Target only baseline means we are then performing the experiments without source information. We are getting 8% approx increase on ENN model, ENN. So in this way, we can conclude that our work is performing better here. And so here, what we can conclude with this work, that background knowledge, mobility detection by contrastive learning, and visual emotion recognition contribute significantly for misinformation detection here. So we have also performed some case studies and error analysis. So when we are adding background knowledge, and then what happens, it classifies the instance correctly, and when we are removing this background knowledge, some of the instances may not classify correctly. So novelty also catches in some of the instances, like if the location are different and image is same, but the location are different, like some event has happened in Kolkata and some event has happened in Pakistan. So like that, or some event has happened in India itself. So based on the location, what is it? This model is able to catch that the context is different but image is same. Now emotion added signals also work here. So after analyzing such type of examples, what we have seen that we have again observed there is some error also. Means sometimes emotion mislead the actual level, and sometimes novelty also mislead the actual levels. So here, this is the another multimodal work. Here, what we are doing is we are just concatenating text and image, and we are passing it to a fusion layer, and then we are classifying whether this news is fake or real. So this is just there is a slight difference between these two. In that case, image was real, but text may be different. But in this particular work, there may be some kind of tampering in either image or in text also. So this is also the similar work here. Just we have used fast text embedding and to while STM layer attention-based mechanism for the textual feature extraction, and for a visual feature extraction, we have used some CNN-based architecture, and then we are combining these two representations and finally passing it to multi-layer perceptron network. This is very much similar work to the previous one. Here also we are getting good result as compared to the existing. So since time is very less, I'll go to the conclusion part. So as we have discussed these works, we have observed some research some research gap like lack of large-scale multilingual data sets here, especially in the code mix and low resource languages. There is some poor cross-lingual transferability. Also, like sometimes when we have developed the model for high resource languages, it may not work for the low resource languages. There is some vulnerability to generative AI also. Nowadays, many AI generative misinformations are getting propagated on social media. So the existing models may or may not be able to detect such kind of misinformation. So to fill these gaps in the future, somebody can work on comprehensive multilingual data sets. We are also exploring on that. So we can build some large-scale benchmark data set for the low-resource languages, for the code mixed languages. We can also improve the cross-lingual transfer. We can also develop some kind of model and data set for the code mixed low resource languages basically. So thus we have during this presentation we have observed that disinformation causes serious threats. Language diversity is a very challenging task nowadays, and we have also proposed state-of-the-art models, but nowadays we can make such improvements in that also. Now we can go forward with multilingual multimodal detection. This is also a critical emerging research area nowadays. So these are some works that people are doing in 2026, that these are some recent works that we are also exploring here. So thank you everyone. Now it's open for the questions.